Um, Maybe start. Has anyone ever worked with infrastructure as code? Just raise of hands. Okay, new to most people. Okay, so that's why you're here, I guess. If you have questions, you can ask them between slides, and I also have dedicated time at the end. So feel free to reach out and questions as they go. Um, so who am I? I'm Andrew Aiken. I do DevOps, cloud security, Kubernetes stuff, GitOps stuff, a website, some articles and security related stuff, Terraform, Kubernetes, bunch of random stuff. Okay, so what is infrastructure as code? It's pretty much the ability to provision and manage infrastructure. So this could be cloud resources, local files, through code and through a repeatable process. Um, why do you want to do it? It's removes the time consuming portion of doing it manually, and it's doing it manually is prone to error. Um, Time consuming, it's you can't scale it as easily. So if you ever spin up 50 servers by hand, it's going to take a lot longer than just setting a variable to 50 and pressing a button. And there's two main approaches to infrastructure as code, declarative and imperative. So one way is to define the orders you want to do it. The other one way is to pretty much say what the end product is. So pretty much declaring it or imperating it through process. Why do we need it? Repeatability, as I mentioned. Doing it manually is a lot of work, and it's a lot of work. You don't want to do that. Automation goes hand in hand with that. Infrastructure tracking, so that allows you to have the repeatability on the same resources. So if it's already applied, don't change it. Standardization, it allows you to have a standardized set of resources. So we're manually or doing API calls, APIs can change. You want your infrastructure as code tools to be API agnostic, where the same version will do the same thing. Shareability, it allows sharing of the exact same resource between people. Since it's code, you can share it. Where doing it by hand through like some console, not so easily. Some tools that exist. So we have Terraform. That's what this kind of will be covering. You have OpenTofu, which is a fork of Terraform. I can cover that later. Plumi, which is a way to code in a native language like Python, JavaScript. I think there's a few other ones that supports CloudFormation. That's an AWS agnostic tool, pretty much. And then the Ansible, which you can also do, but that's getting farther away from the infrastructure's tool or infrastructure code tools. Terraform, so it lets you define your resources you want. So it's gonna be your cloud servers, your files for whatever, in human readable and machine readable code. They focus on the higher level abstractions, so you don't have to define everything, every resource. Like it's not API calls. It's defining high level. What do you want? A server. What settings do you want? And then so forth. The workflow is pretty much you write it, you plan it, so you run command, it'll show you what's going to create, and then you actually apply it. So that's applying against your existing resources. The plan also shows you what exists in the state, so I'll get this later, but it shows you what you currently have and then what you're actually going to do to it. So it compares what you've written to what actually exists, and then you can apply the difference between the two. I have a link to install. You don't have to follow along, but if you want, you can kind of install it and mess around with it. And I'll have a demo later of actually going into that. Providers. So this lets you connect your Terraform with a SaaS tool that offers APIs. So this could be AWS, Azure, GCP, Kubernetes, local files, and there's thousands of other ones. So if you can think it, you can probably do it, and you can write your own. So pretty much all it's a binary that just knows how to talk to APIs and use your local configurations to talk with stuff. Yeah, so here's an example. So pretty much in a file, it ends in a .tf file, so Terraform can know how to read it. Pretty much define the name of it. So this is mycorp.mycloud. So this could be HashiCorp AWS. So this is defining the AWS provider, so spinning up an AWS server, plus the version, then you have to do some configurations. So in the case here, just some example. But if it's AWS, you'd be like region equals US East 1. Some configurations. In theory, you could store credentials in there, but you shouldn't, because you shouldn't have them in code if you're sharing it. Resources. So this is pretty much the building blocks of Terraform. So it allows you to define a unique resource that's creating a resource, either, in that case, a local file, This could be an AWS server, any resource if the provider support it. So here, I'm defining a local file, giving it the Terraform name example. These two, the local file and example, have to be unique to the whole environment. The content is an argument you add to it, so contents of example file, and then the path is another argument for the local file. And then here's an example with AWS.
Thank you.
So, example of AWS, a VPC, pretty much a building block of AWS. All you need is an argument of the site range, and then you can create it. And then if you have to return arguments, so let's say you need to make a subnet, you need to know the results of some command, they'll offer the output. So in this case, we have we're finding a VPC. Once it's created, we can reference the ID of the VPC, AWS VPC, the name of it, so example, and then the ID of it. So this allows us to build pieces together instead of having separated things that we do different calls with. So it allows everything to have dependencies and then allows you to build off each other. State. So how do we actually track what we built so far with what actually exists that we want to build? So that's what state comes in. So there's two types. There's local and there's remote. So local is just a file on your file system that pretty much tracks what is existing, what Terraform thinks exists, and then you compare that with what you're actually writing as Terraform code. And then the difference is what actually can change. So when you apply it, that's the difference. You also have ways to store it remotely. So S3 is your blob, so these are object stores. So this allows you to work with a coworker on the same project. You don't have to share files, which could be confidential, or keep it all secret, keep it all secure. And then Terraform Cloud is their managed solution that offers state. And using there we go. Go back and forth. Here's an example. You're just at the back end, so saying it's local backend, so this is where the state's going to be stored, and then path to it, and then you're all set. That's the simplest way to do it. And then, okay, so the pictures aren't showing if I it's not idea. Go back and forth, they do. Okay, cool. So dealing with data. So let's say you want to reference something that you don't want to be managed by your Terraform files. So let's say it's the shared secret, in my case. This could be a shared VPC, like we defined earlier, but you don't want to have everything in one giant project. You can do data calls. So this is pretty much saying, instead of managing it, you're just calling, asking for some resource. So here, I'm doing a data call for a secrets manager version. So this is a way to store secrets in AWS. And then we give it the secret ID, and then it'll return us actually the contents of the file. This is a way to not define them baked in your source code, so your community get, you don't want your secrets in there. You can do it safely in a data call. And this offers a lot of other functions for data other than secrets. You can do data files, you can do anything that's pretty much a resource, you can do as a data call and just retrieve that data. So allows a little more modularity of resources. I'm going to go with command line. So command line has, if you install that a few slides back, kind of go installing it, but there's some subcommands. So initialize, the init, it pretty much pulls all your providers. So this is your AWS, it pulls the code that you need for that to run that locally in your file system. Any modules, I'll get to that a little later. Which initializes it, gets it ready for you. The plan will show you the difference between the remote state and your local configurations. So this is in the Terraform workflow that they define. The plan is to show the difference. Then apply is actually going to apply the difference between your local and your remote resources. And then destroy is doing the opposite of apply. It's destroying everything you have. So don't run that on production, because you can destroy everything. So there's safer ways to remove stuff. Not going to get into that. Validate just validates configurations to make sure it's formatted and looks good. Format actually formats it for you, so it's kind of handy to make it all look pretty. Few things with state. So state is that remote store for storing objects between your local and remote. List, you can show everything that's managed by Terraform. RM just removes it from being managed by the state. So this pretty much removes it from the connection between being managed by Terraform and being managed by something else. So this allows you to remove stuff without actually deleting it. And then import does the opposite. It pretty much pulls in an existing resource, so it's managed by Terraform now. So you don't have to redeploy it. You can just use an existing thing and import it. Other concepts, modules. So this allows you to reuse code. So if you're using code, modules are great. So there's a bunch of public modules out there. I can show you later. But a bunch hosted by AWS, third parties. They're great. You can pull them locally, modify them, show them locally or in your own org. Variables, input and output of variables between modules and your local configurations. And then same with outputs. You can retrieve data from modules and output of modules. Or to standard output if it's, yeah. I'll show that later. Okay, I'll kind of do a demo. I have the slides if you go to that link and bring it to GitHub. The slides are there and then some example codes there. Cool. So in here,
Can you zoom that a little bit?
yeah. There you go. Cool. I'll just define. So we're earlier the provider. So we're going to use the HashiCorp local provider here at this version. So this is saying we want to deal with stuff with the local file system at this version. And then what backend? So we're going to write everything local to a remote state file here. So this is going to be in this local file system, not managed in S3 or anything. We can then define later the local file resource. So this is a local file, just a file. Content, just foo exclamation, and file name. Simple. Let's run this. Let's see. Directories here. So this is the main.tf we're looking at. This file here. Initialize it. So it's right here. You can see it's pulling the required providers. So this is saying we found here earlier the version. You could do like greater than or some logic there. We want this specific version. It pulls it, initializes it, and now we can look in the file system. We see there's a lock file. So this is like in other programming language, locks to validate different versions. And also in .terraform, as you can see, we have a provider for local, some binary for this provider. Next, we can run the plan. This is going to show the difference between our local and our planned output. So your plan, this is the one resource we need to define, the local.example. Contents there. This stuff's going to be known after apply, file permissions, and the file path. Let's apply this. So when you run apply, it does a plan before that, and then it prompts you to apply. So yes. That's fast because it's one resource and it's local file system. If it's like an API to AWS, it's longer resource, it may take time. It depends on the resource. Now you can see this example.txt, example of file.txt exists now with the content we provided.
So what you deployed is the file?
Yes.
Okay.
In this case, you can do AWS, you can do anything. Example file. Let's change this. So instead of let's remove that exclamation. With look and it's run a plan again. At least for it. You can see it wants to replace it because a bunch of the hashes changed, the file changed. So we're going to see it's going to replace it. In some cases, you could have to see it's going to be modified. But in this case, since the file changed with the file provider, it's going to replace it. So we're just going to change from full exclamation to just foo. If we apply it, it's just the same plan. And if we apply that, see now it's remove the exclamation in this file. So next, let's go to data. So this is pretty much going to call a data file. So it's going to retrieve data from the file. And the file name is source.txt. But this is the contents of the source file. So it's going to pull that data into Terraform. Then we can reference it in a new file. The contents is going to be the contents of the source file. So here we're going to define the data. So data.localfile.source. So this is referencing that resource and then the contents of that resource. So that resource block of the data returns the content. If you run it from apply, I have to save the file first. apply. You can see that's going to create, as you can see here, it's reading, see this source, so it's reading the file, takes 0 seconds, and this is now, it's pulling the contents of that file. And now here we have the destination, and it's pulling the contents from that variable, so this contents here, and then putting it to the destinations file. And now we apply it, and we can see the destination has the contents of the source. That's high level of what you want, really not what you want to do with it, but high level how to use it. Any questions on those?
If you're, let's say, going to add a resource that would cost you money, will it sort of give you a heads up, hey, you're
Not by no.
Okay.
I know there are probably extensions I think there are some extensions that will tell you, like AWS, you don't want to spin up. But you definitely have some knowledge of what you're doing in the first place. It's not going to tell you, but I think, I don't think anything by default will tell you cost. It's more agnostic of providers.
Got it.
Any
I
other
have a
questions?
question too.
Yeah.
If you were deploying, say, like a change to an existing server or something like that, where there might be a lot of information, are there tools for understanding the change, like what you're going to change better? Right, because right here it seems like you might end up with a wall of text.
It can definitely get wall of texty. But in most cases, if it's doing a change to replace, like here, it was replacing it, so it's completely removing it, recreating it. It's pretty much replacing it. If it's a change, and some of the cloud providers will actually pick up that change, and it'll just show what's changing instead of here it's everything. But if you're still doing a lot of resources, it's still going to be a lot of resources shown there. Show off some of the stuff with the Terraform registry. So here's the Terraform's website, where they host a bunch of the providers. Zoom in a bunch. The providers, and then modules here. So you can see this is the local one we used, and we specified which versions. So here's the latest ones. We can look at the documentation. So pretty much all providers have a documentation page on this website. And it kind of goes into resources, so you can see the local file here. It's pretty much what we used, so and they give examples and then usage. So pretty much I copied this and just reformatted it. So this is how to find stuff, and then same with data files. They give you great examples here. Let's go Terraform. Oh, not Terraform, it's AWS. So this first party one. There's a lot of resources in AWS, so let's look at like.
Unknown caller.
Scroll through it. That's it. Now let's just use some like. There, instance. So this is an EC2. It's pretty simple, and AWS does this dedicated server. So, you give you a bunch of examples here. Just grabbing like data calls. So this is, for example, for data call for the AWS AMIs. This is a machine image. You can do some data calls, different arguments to filter out and get the most recent of Amazon Linux here. And then we use that data here for the AMI. So they specify that from an argument that could change over time to get the latest version when you launch it. And then a few other arguments for spot pricing. They have argument references, so this is what you pass in. So here's the AMI used earlier. So you can pass in, and then give you a bunch of list of different ones, and a little good amount of depth. And then here's the attribute references. So this is what actually gets passed back once you apply the resource. So when you create the resource, you get the ID of the instance back. So let's say if you define that somewhere else, you can get that back in a file or as a variable to output to screen.
Just curious as to whether or not there's extensibility for custom providers.
Yes. So I know I'm not going to get into this talk, but I know there's definitely a good amount of documentation that HashiCorp puts out for creating providers. It's usually compiled, but probably it's anything that you can talk to yeah, I'm not sure offhand. I've actually never worked with it, but I know it exists, and but it probably if you're looking for it, it probably exists. I know providers. Too much. Here. The big ones, but then there's a bazillion other ones, from Kubernetes related stuff to cloud and time and TLS. So there's a lot of, if you can probably think about it, it probably exists by someone who's already published it. Just 80 pages of just 4,000, just these, but, and then same with modules that they're published here. So let's go to the first one. So this is an example of setting up AWS IAM resources. So this is identity management in AWS. So the example how to reference it by calling a module and then the source and then a version. And then if you get to the examples.
Besides being that it's not working with containers, is it safe to say that there's a fair comparison against Docker?
Not necessarily, because Docker this is more generalized to.
Sure.
Well, I think there's probably a Docker way to launch it with Docker. So probably as a module for running a container locally on that. You can run like local file system commands. This is more for managing resources where you probably could spin up Docker containers with Terraform, but you also spin up the EC2 instance, the VPC that resides in the load balancer that it's pointing to, everything, and then manage it over time. Where Docker itself is more of just managing Docker containers on an instance. I would say it's like the orchestration of the cloud providers, but you get the point.
Yeah, well, just looking at the Terraform file, even it looks
Yeah.
pretty similar to the YAML syntax.
Yeah, I think it's HCL is their markup language for writing it. So here's an example for the module, which gives you some inputs and outputs of what you're passing into it. Actually, find a better one. So we have arguments you pass into the module, and then some outputs. So it pretty much handles all the thinking behind the scene. And it's on GitHub, so if you want to look into what it actually is doing, let's go to the file, zoom into that file. It's using in submodules from that module in different, it's not being any variables, but you can see it's AWS provider, so it's using AWS. Some of the resources, so these are pure AWS resources, it's just abstracting it, so you don't have to do it, but there's the security concern of abstracting it, where if you're not managing the state, you may want to set that a tag so it doesn't get changed in the background just for security reasons, but it's not a huge concern if it's from AWS, I guess, but considerations. And I'll show just outputs. So outputting in variables, so output in a module returns it from the module back to where you're calling it, so like a return function in a programming language. Let's get the output. So this data source, let's just output that to standard output if it's on the first level. So it doesn't have any dependencies. You can give it a description. It's not sensitive. And let's just call the source. So if you're in a plan, it's going to show the output. So this is a way to get standard output. Or if this is a module, actually pass it back to the module above it. And same with variables. You can pass variables or local variables in a module, so you're asking for information. Or if I do a variable here, move defaults, it's for a string, and if you're going to point it, it's going to actually ask us for an input here. So what's the name? Doesn't matter because we're not actually using it, but you could use that in your code. It's probably not best practice to use variables from the command line. It's better to have them either calling it from data, so from like a secret store as in my example, or from some configuration files that are configurations, not secrets. Any other questions I can kind of, yeah.
Can you talk a little bit more about the declarative versus imperative styles of writing Terraform code?
Yeah, so pretty much in Terraform it's more declarative, where it picks up the final state, so it does all the thinking of, it doesn't matter the order you write your code. Where something like Ansible, it's more implied of the first resource, the first mod task is the next, and the next one, and they build off each other. Where Terraform will actually look at the dependencies. So in this case, we have the dependency between calling this data file here. So this is dependent, getting the return of the data before we actually can write to a file. So this is how it picks up the dependencies, and Terraform does all that thinking on its own. You can definitely break it if you do more logic in there. But it's pretty good on basic just referencing other outputs, and it'll.
So you could switch the order of those two functions and it would still run?
Yep. So it doesn't actually matter the order. So it's no changes because it doesn't matter. And right now I have everything in the main file, but you can also do subfiles. So just like data.txt. Let's move that data call out of here and into a dedicated file. And it'll look in the current directory for anything with a TF extension. So it's same right here. So no change. But if you have in a subdirectory, you have to like reference it or. Yep. So it doesn't matter the order. It's kind of how it picks it up.
So there's no, I'm sorry.
No.
So there's no like import or something to try to find these other files. It just reads them all.
Yep. If you do a, how about state? We can show all the state things being referenced right now. So the local file, the source file, the destination file, and the example file. Those are everything in Terraform is picking up as resources right now. So those are ways to actually reference a state. So kind of like how to look for what's being managed. It's not telling which files are being managed though, but what's being picked up in that state file. Same with if you want to remove something, you could remove from here, the Terraform state remove. And then just this is the state file. Scroll a little bit. It's a big file of everything Terraform manages. You shouldn't manually touch this. It does all the content. So here you can see the data call for that file, the local file. It's the hashes and comparing your current with, and this will compare the current file versus your desired file. Same with all the other files you define. You know, it's pretty much picked up and managed in this state file.
So can you break Terraform by going outside of Terraform and messing with these
Yeah.
resources, and then this doesn't correspond to reality?
Yeah. And it also makes a backup usually, so but you shouldn't manage these locally, so let's just run a plan and see what happens. So it looks like it picked actually bear with the data I want to call. Let's remove this managed file. Actually, I'm changing the backup file, that's why. Okay, let's remove the actual file. So let's remove this managed file. So this local file, the destination file is going to be removed. Run a plan. You can see now it's what's created because it doesn't exist in its state file. So now if you just apply it, it now is picked up, and now it's probably going to regenerate. You know, if it's changed in destinations, it's the example file, which are removed. But now it's going to pick up no changes because now it's being picked up back into the state. Now it's managed by it. So probably don't want to do that normally, but kind of shows, and then creates a backup. So. And then the S3 and like remote stuff, you do versioning so you can actually compare it over time. So
What's your biggest pain with Terraform?
I'd say I haven't had too many, but some of the stuff with like I don't know, I haven't had really too many. Kind of been smooth sailing. Because one thing is like the open source licensing with OpenTofu. I'm not sure you guys follow that, but the Terraform changed its licensing from open source to like the business license or whatever, which a lot of controversy back last fall. So that's why OpenTofu is a fork of it when it's open source, and now it's a little controversial, but it's kind of it's not too bad. And Terraform is still being worked on. It's more internal controversy between like open source and.
So do you need to pay a license now?
Nope, it was mainly it's source code available is how instead of open source. We can still use it. I think it's more if you're using it as a product, like selling it as a product, like managing it. Terraform offers or HashiCorp offers Terraform Cloud, which is their managed backend. They manage the deployment, so you can pull your latest git commit and reapply it and do some review in there. But there was third-party companies that were just doing that for them and hitting their margins. And they're supporting the core code, so it's kind of
Yeah.
that's probably the reasoning behind that. So. Any other questions?
So, like when I was doing database migrations, I'd have a script migrate and another script to revert it back in case there were problems. Is that sort of, do you do that with Terraform, or does it handle that some other
It
way?
doesn't necessarily handle that, but if you have it managed by like Git or some state based, you can just revert a Git commit and it'll try to roll it back. Of course, you can still apply something that you can't roll back, other than like redeploying it. So like a database, I'm thinking like AWS might work in there a lot. If you're doing an upgrade to a database, you can't really roll it back as easily as applying it. So things like that, it's not suited for. But for something that's like, oh, it's changing a security group rule or some file, if you revert the commit and then reapply it, it'll see the difference first you're applied and then revert pretty much. So there's no built-in revert. Yeah. Other than your code is your what it's looking at to revert.
When would you use the Terraform state import or RM commands as opposed to just making change to the?
Yeah, so let's say you have some resource you're managing, say an AWS server you're managing, and you want to or don't want to manage it with Terraform anymore. So let's say you want to keep it, maybe testing it, but you want to spin up a new server. You can remove from state, so when you run plan, it'll show it's creating a new one, and it dissociates what actually exists, what you have deployed. So that when you actually destroy it, it won't destroy that server that exists. So that you want to do some debugging on why breaking. You could remove it from source, from this state file, apply a new one so it's still running in production or whatever use case you had it for. But you can still debug it, and then you could remove it. So it's and the same with import. So let's say you already have a database running or some server running, and you don't want to create a new one, or you've already data in it. You just pull it into source in the state, and then it's now managed by Terraform. Any other questions? You have to depth if other languages open and stuff. So if there's questions, feel free to.
So how would you compare it to some of the other infrastructure as code tools like Ansible or I guess Puppet is Puppet one? Or?
Yeah, I'm not sure Puppet's really used for managing infrastructure. So, like with Ansible, I know you can spin up servers with it, but it's declarative versus imperative. They're written in different ways. Where Terraform will show you the differences between your current infrastructure and what's actually going to apply. So, say it's going to change one configuration on a server, where Ansible won't even show you; it'll just run through it all and auto apply it. So there's different function use cases for them. So you could use Terraform to actually configure the server, like run a bash script on the server, but that's probably something that's better suited for Ansible, where it's where it shines. It's another tool that I mentioned. It's a way to write infrastructure as code, but it uses your default language. So like here's Python example. And it'll manage the backend too. It's another tool for it. Something I prefer Terraform because it's more readable, and this one you do more logic though. So if you want to do something that's really baked into your code, but I know this is picking up traction, so another cool tool to check out.
Does it have tie-ins like with VMware, where I could tell it before running and make a snapshot of the server and then apply these things?
Yeah, so it's VMware. It's probably a provider for VMware. vSphere.
Yeah.
Yep. Documentation. So they have like all their networking stuff, but it's like snapshot. vSphere snapshots. Looks like you can run it. Make a snapshot. So you can probably run that and have that be a dependency of actually changing the server. So once that's completed, then you change the server. So let's do configurations like that and take some hands off and just press a button and hopefully relax. But usually if you're doing something in production, you kind of want to monitor it to make sure nothing goes too wrong, because it could still go wrong. You do it manually or you do it through here. Still, human error is less involved, but it's still there. So I'm going to start the code.
So, is this something that you use like in place of like AWS, or is it something that you incorporate?
Incorporates with it, yeah. So in this, you could spin up here, and they just want to, but instead of like manually clicking through the console or API calls or like AWS CLI, you could use this instead, and then it'll actually track the difference between what your deployed server is and what your code says to deploy. Yeah. Sample of example of using it with we managing lots of servers. So this is a competition we ran, but on AWS. So we'd find like teams, but here's an example we're calling modules. So here's just a minute more modules. So this is defining your VPCs. So this is networking in AWS. Bunch of other stuff, but they're defining EC2 servers. So just mention that. Dive into that one only. Server. So let's go like for Jenkins. So defining a server image, what subnets they belong to, key name. So this is how you tie in with AWS. And then this server will be applied once you from Terraform apply some data and then other changes. If you change that manually, it'll show the difference when you're on the plan. Data calls for data. Yeah. Yeah, I think I have questions. I have some resources here. This is a link to if you go to the ISC here, a shortcut to it that has the slides and example code I had. Some different resources. So this is the development docs. So this is kind of get you running with how to use Terraform in the first place. Interestingly, they have some good docs they have a certification, an associate certification. Kind of goes into what's infrastructure as code and fundamentals and all the workflows and subcommands, creating modules. They've offered an exam. It's a pretty good exam, but it gives you high level of basics. And then they offer it all for free here, examples, and so their support is pretty good. And there's a good community online working on this. So looking up your issue on ChatGPT, pretty good because there's a lot of issues people have run into. So it'll scrape that, and then have some sources. But yeah, any other questions?